Today's video is brought to you by ProjCAD, found at projcad.com. This video is dedicated to showing how to draft 3D objects in a 3D computer-aided environment, CAD program. There are three components to keep in mind in any 3D environment: the Z-axis, which is pointed up and down, the X-axis, which is pointing to the left and right, and also the Y-axis, which is pointed to the front and back of where you are standing. We can spin, pan, and revolve this environment in the computer-aided program from any point in the environment of where the axis is aligned. A green dot will appear where this point is assigned, so the user knows where it is being manipulated. This is achieved by pressing and holding the Shift key while pressing the left mouse button, then moving the mouse in any direction, which causes the objects to spin accordingly. We may also want to pan without spinning the screen by holding the middle mouse button down and move the mouse in the direction you wish to pan. That covers some of the fundamental functions of viewing any 3D objects in the working environment. When we start ProjCAD or AutoCAD, the XYZ icon will always be located at the 000 point in space. Depending on what the user is doing, this can be critical in some cases for architectural or civil engineering plans and helpful when working with 3D models. We want to show a brilliant method to start any 3D model and get an easy setup so we can easily see any point in our model in many different fashions such as wireframe, conceptual, and many more styles. I like working with X-ray when I am joining and moving objects from one point to another so I can view all snap points. We will show how to add layers from a docked layer control panel and then look at the Properties dialog box. Both the Layer and Property dialog panels can be docked anywhere on a single or multiple monitors. This is a layer control panel and is important in some cases because it gives us a method to easily turn off and on some objects so they will be easier to manipulate. For this example, the layers will not be very important since we are combining all elements as one object, but may be for more complex objects. This is the Properties control box, which allows us to do a lot of things on a finer manipulation degree. Now we will demonstrate how to create the cube shown in the previous examples. First, find a good font that will be good enough to show as an extrusion within the cube. A fatter font will be better since it will be easier to see from a distance. Since this text will be just one letter, we choose to use a mtext text object. Enter X on the first line, Y on the second line, and Z on the third line. Now we need to explode the text so we can manipulate each letter as individual objects, and the only method to explode text is with a command called txtexp. This cube example will help some users to get a better grasp on the concepts of creating 3D objects, and as you will see is very simple to create once we know the secrets. Since our text is now exploded as individual line elements, we have to use a command called extrude to get them into a 3D object. This command expects only a height, but can also accept a point in space, which is not as precise. You will notice a short line that demonstrates the height. Our inputs will rely on precise measurements to align the text within a dimension cube, making the process easier. We will spin the model so we can demonstrate that all surfaces are indeed solids. Now, let's create the cube that the text will be inserted into. We will use the box command since it creates a simple box. We can enter a small enough number here to match the text. Enter a number 3, press Tab. Enter number 3, press Tab. Enter number 3, and press Enter. Now we will align each text object to each correct face of the box. Enter a line in ProjCAD prompt, ALIGN, then select each extruded letter individually. This 2D Align command will only ask for 2 points of selection. There is also a 3D Align command that will have to be treated differently from the 2D version. Notice carefully that each point that is being selected here. The corner vectors chosen are along the same plane as the box and the vectors of the box. Now we have to move the letter to the center of each box plane. Since we know the dimensions of the box, we can calculate the movement distance. The Y text will be tricky, but if we select XYZ corner vector point, this shouldn't be a problem. Use the Align command again. The Y text will be tricky, but if we select XYZ corner vector point, this shouldn't be a problem. Use the Align command again. Notice that moving the points to a height vector point that the text will end up as required. Move the text as required. Objects can be aligned with any face in your model, so long as the corner vectors are dragged to the right point. Now that we have all objects placed on the proper face of the box, we can now move the extrusions into the surface so we can cut them out. To do this, select each letter and move it halfway into the box object. A move command is used here. Move the letter from the end point of one corner to the midpoint of the text height into the box. Do this for each text object. You can spin the box to ensure it is intersecting the box. Use the Subtract command to remove the text object from the box. Select the box first, then each letter. There should be a void in the box when it is done. SUBT or ACT. Move the box near the UCS 000 icon to make it easier for the user to see the coordinate imbalance. Notice that the icon size changes whenever the coordinate of the icon does not represent the original coordinate point shown on screen. The box has now been molded to make it as one object. Once the users are comfortable with drafting in 3D, this exercise will not be needed for modeling any longer, but we use it as an example of some basic steps to create 3D models for 3D printers or ideas for design. The next section of this video is why we created this model for anyone new to 3D modeling to make it easier to understand. Let's take a moment to explain the UCS, or User Coordinate System. This is a vital step to allow users to assign a point in space that they can recall immediately, so they can return to points in space that will make it easier to draft face or side view objects, as what we want to explain today. We first want to explain another example of why the origin point is so important to 3D drafting. We have to always know where we are in space, but also we can look at an object from any angle in space. This block gives a perfect example of where we are and defines it for the user. As soon as the view is changed, the point will be lost forever, and without a definition of where it was is impossible to achieve again. To define a coordinate in space, we can use a command called UCS, which stands for User Coordinate System. Recalling a defined point enables users to revisit the same point and viewing angle from which it was captured. In this tutorial, we want to define 3 face-space definition points. We will be using 2 commands today to set up these views. The first one is UCS, and the second one is PLAN. Please take a moment to pause this video and familiarize yourself with the commands and look at them up in your CAD program at what each function does and its options. To achieve this, enter UCS. The UCS command will ask for 3 points. It is very important which corner of the box is picked first for a particular view because this will define our new 0, 0, 0 origin point. Secondly, any point along the y-axis can be selected since it is only used for direction. Then finally, any point along the z-axis since we are only concerned with direction. Now enter a command called PLAN, P-L-A-N. This command will rotate our view to the coordinates we defined with the last UCS. It is important to save the view so we can recall it easily. I like to use one-letter views, which makes getting to the view without spending time typing, but sometimes it may be better with longer names to be more recognizable. Use whatever name is comfortable to you. Do this name save before moving to the next step. It was at this moment that I realized that my alignment command did not work as I had hoped. Since the text is indented into the box, it is not impossible to remove it, but it's best to do it right the first time. Continue these 2 steps of defining coordinates and name saving for at least 3 faces. When switching to a plan view, the first picked in the UCS command will be at the bottom of a plan we will be drafting at, so that positive numbers can be used in our next demonstrations. Now practice recalling each of these views and make sure they align as to what you expected to see. Then we can move on to the next demonstrations of creating useful objects for a 3D print. WBlock is a command in CAD that saves any selection of objects to an external file as a DWG format. The only method at saving a drawing with the UCS and UCS names is to save the drawing they were defined in. WBlock or WriteBlock will not work to save all the definitions of the drawing setup we illustrated in the previous video segments. For the next exercise, we will model a phone carrier box to the possibility of mounting it in a vehicle or for carrying. We must first measure the phone for width, height, and thickness. We are only concerned with the inside dimensions as we have to consider at what strength the material wall thickness will be sufficient. We can see from this chart from Bamboo Labs that we can choose the best material for the job based on structural properties. This image is a preview of our ultimate goal. This phone carrier box image will make it easier to follow along with what we are doing. Based on the X, Y, and Z box example we demonstrated previously, we can create a phone box by simply using few commands of polyline, box, extrude, subtract, union. We rely a lot on our 3D drafting skills using these simple functions. Let's start out with the polyline command. PL is a shortcut key. Given the dimensions we determined earlier, we can enter the base of a starting box. We use polylines, a single-line element, to make it more understandable for this task. Make sure your orthographic axis lock is turned on so the lines will not go out of Y-X axis. Enter the lengths of each side of the box as required. Once 3 lines have been formed, we can use a close command C to close the box. This box represents the interior of the box since that is what we measured. We added spacing inside the box to allow our phone to slide easily in and out of the box. We can now extrude this box to the height of the phone. Our next task is to define the thickness of the box and to draw another polyline so we can use this as the phone case. Once a user gains skill to plan, the next steps will be beneficial to the steps we use now. To define case thickness, is best to sketch out a polyline to the interior space, then we can simply offset the required thickness. From here, enter the desired thickness of your case and make sure that only the polyline is selected, then enter a desired distance. Since this is the camera case body, we have to make sure the polyline is the same thickness below the interior as it is on the inside before it is extruded. You can browse through this section, then revisit this section again if it is not clear what we are trying to do. We can always go back and review our previous user inputs by pressing the F2 function key. This allows all our commands to be visible since we started this CAD session. I am looking for a distance input number I used previously. Since our ortho is a term used for staying in the same plane as some other points, is turned on, we can select a point in space at the same height as the top. Now that the polyline is created, we need to offset it to the thickness of the box. We are using 1/8 of an inch. Now we need to move the polyline down to the same 1/8 of an inch below the distance of the void box so we can then subtract space within the dimensions of the phone. Now that we have moved our phone extrusion below the bottom of the case, we can extrude it to the top of the box. You will see why we don't want to extrude it above the interior void in just a moment. The purpose in this current polyline box is to get a good height reference because offsetting a line outside the exact dimensions of the box will not be exact height. This illustration shows why. Now we know that we can use this temporary polyline as a reference to get a good height. 3D drafting takes some experience to know what to do at the appropriate time. That will only come once your skills in coming up with shortcuts that will aid in the actions shown. With 2 polylines drawn, I will use one to extrude and the other line as a height reference. Pay close attention to which line is extruded and which is used for height. The extrude command asks for object first, then its height. I use the midpoint of the polyline, but I could have easily used the end points. Extrusions can use any easily snappable point, so long as they align with the height required. At this point, we are going to void out space within the box using a command called subtract. It will ask us to select the outside object that will remain first, then we are asked to select the interior space object. Now we have created an open top box object, but we have to create an open front so we can see the phone face. Now we have created an open top box object, but we have to create an open front so we can see the phone face. There are still two polylines left within the model. Find them using a window, then modify the lines to fit our next parameters. Only the line close to the void space will be needed, so remove the line near the bottom of the box. Press the Delete key. Create a window to select the desired polyline. Move the line up 1/8 of an inch. Let's take a second to explain some of the basic advantages of snap points. There are many handle objects associated with what these snap points can do for manipulation of the lines, arcs, blocks, and most objects with the CAD file. Experiment on your own to see what they can do to the object you have selected. The type of objects selected affects what you can do with their interactions and may change on what the objects are. We can move lines, rotate objects, scale entities, and many other manipulations based on its properties. Of course, there are many other factors that are dependent on how snap points can modify the objects, such as axis lock, grid snaps, but there may also be hidden factors that may also hamper its movement, like height, to name a few. Since the polyline is within the bonds of the solid, it may be best just to grab the line's snap points. We need to offset the boundary of this polyline to 1/8 of an inch so we can subtract the space for an opening. All we need to do at this point is to move the front line to the outside of the face. Now extrude the polyline above the height of the box solid, and since this is just a void, any height will do. The next step is to subtract this void from the box using Subtract command. Spin the box to make sure it is how you want the object to look. There are many levels of a command called undo that will go back to the beginning if you like, so don't be afraid to experiment to get what you want. Spinning the objects is always the right thing to do to make sure you are on the right track. Notice there are some sharp edges on the corners that may cause some discomfort on skin or the phone, so let's look at a command called fillet. In order to use it correctly, we have to have two corners selected. The fillet command will ask for a radius, then selection of one corner, then another. The corners must be adjacent to each other. Do the same for the void space corners. Now spin the object again to see if it matches your specifications. Thank you for watching. Please like and subscribe for more videos.